In a complex network environment, a security analyst detects suspicious traffic patterns that indicate a potential advanced persistent threat (APT) attack. The analyst suspects that sophisticated attackers gained unauthorized access to critical systems and attempting to exfiltrate sensitive data. The organization relies on multiple security layers, including firewalls, intrusion detection systems, and endpoint security solutions. What should a security analyst prioritize as the initial response strategy? Answer the question. So, an engineer has created a bash script to automate a complicated process. During this script execution, this error called permission denied. Which command must be added to execute this script? So, next questions. What is the principles of infrastructure as code? Back to the question, what is the purpose of having a system? Hello, you're welcome to 591 Lab. This is Cisco certified CyberCOR professional, performing cyber hubs using core security technologies. CBRCOR 35201. Alright, let me first of all tell you about 591 Lab. 591lab.com, pronounced as 591 Lab, is a top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certification in Cisco, Huawei, Harvard, Juniper, Palo Alto, and Fortinet exam track. Alright, moving into our agenda today, looking at security technology for monitoring, threat detections, and response. Incident response, bash scripting and access control, infrastructure as code, orchestration and automation, and lastly, defending systems and devices. Focusing on system handling. Alright, going straight to our first question today. In a complex network environment, a security analyst detects suspicious traffic patterns that indicate a potential advanced persistent threat (APT) attack. The analyst suspects that sophisticated attackers gained unauthorized access to critical systems and attempting to exfiltrate sensitive data. The organization relies on multiple security layers, including firewalls, intrusion detection systems, and endpoint security solutions. What should a security analyst prioritize as the initial response strategy? Right, looking at before we go into our options, first I would like to give you some things of scenarios, and then we'll come back to the question. Now I have a topology here, and I'll simulate this topology whereby we have a router here, and our router is hosting a firewall as well as intrusion detection system, which is not. Then I have an internal users, so then there is a server which happen to based on the scenario also to be an external server, a hosting web server outside the organization network. So looking at it now, this server is hosting the malware. You're getting it, like a virus, and then a host will actually download this malware. Then we'll use our intrusion detection system to be able to detect that. And after we detect that, then we can set some firewall rule to block the users from being able to obtain that kind of malware anymore. Are you getting it? Okay, so we are going to do that now. So quickly, I'm going to log in to workstation. My workstation here now I already have, like I said, I have a host So this my note H10 is the one hosting my that is the one hosting the server, the malicious side. And then we have the H5. H5 happens to be my internal host and the router. So one of these this terminal for the router where I can run my intrusion detection system. Then okay, so quickly without that, the first thing we can do is to make sure that the server is running the services for the malware, getting it. Then we also start our intrusion detection system so that it can be able to so first thing I will do is to first of all check whether my the services are running, what services are running on the server. So by putting nestats-t means that I wanted to show me the TCP, and the option U means I want you to show me the UDP services that are running, and N start for numerical value instead of the main name system. So I want to show me the numerical IP that are running the services, and as well the P stand for to give me some of the results of the processing IDs that are running, and the whole start that we want the output to give us both listing and non-listing services that are running. So that's netstats, network statistics of that. Okay, so I can watch that, and I found out that right now there's no services running. So first thing we do is to start the service of that server to run the malicious server. Right, so then the command for that here, so I have /support.5 _script the man where server _ start.sh. So that's the script for the server to start running. Right, so do we get that? So this is a part to that script. Okay, then I'll start. All right, so then I have to confirm to see whether it's now running. Okay, so by choosing the next start again, so now we can see that we have in this master and this is the IP address. You know, I'm hosting this locally, so then it's running on the port 6666. You get. Right, then the state is what is listed. So then I'll go forward to my R1 to start this knot. All right, so yeah, I can start this knot by .lab so far where I have the script start knot. Okay, so this is the command and on the script. So this is the script to start this knot to start running. All right, so I'll punch that now. So my knot is running now. This knot is standing for the intrusion detection system, the IDN. All right, then the next thing I'll do is to so I'll have another terminal for my R1. What I'll be using this one, I'm using it to be able to detect all the alerts coming in through the snot. The alert of the snot. So I will do that by issue the command tail-f. So this will give me the real-time tail means you should go show me the last logs of this snot alert. You get it. The F keep it running for real-time monitoring. Okay, so that is what I have here. So tail-f, then /var logs and snot/alert. All right, so I'll have that now. All right, so why am I having this is because my tail will give me last logs 5. I'm actually getting it because I've run it 4, but nevertheless I have the 3 logs here. So let's look at what we're gonna have after this now. All right, so now on 5 here, I'm going to send the traffic to this to the server in order to download the malicious application. Okay, the site is 209.165.200.133. So I have the port number there. As we can see, that is 66666, and this is the where I will get the executable file of that malicious application. Okay, so because we're trying to download. All right, so I have this now. Then once I punch that, I should get. You can see that I'm getting some. I get that from my logs. So there's a new entry. So yeah, I have my download there. So 100% complete. So but what am I getting from my logs? And so it indicates that a particular alert, to alert us that a particular traffic has passed through the IDNF, and then this is the alert we get from that into our log. It's a malicious server int, and what is the IP address? And you can see the IP address of the source, which is 209.165.200.325. Are you getting it? And the ports associated to that. Then the destination was 209.165.202.133.666. So which is the one that is within the executable malware file. You getting it? So now we can see how we can make use of IDNS in order to give us that. But looking at it, the IDNS is just triggering an alert for us to know what is going on our network. But it cannot actually prevent. So now we're going to set a firewall rule, so a rule that will help us to prevent this from not occurring again. You get. So next now, but before I do that, just give us some fill permission on that. Alright, so like the topology I have here, then next, so R1 is not only running an IDNS, but also a very important linear space firewall. We call it IP table. So next is to block the traffic to the malicious server, identified before by editing the firewall rule currently present in R1. So the firewall IP table uses this concept of chains and rule to filter the traffic. Traffic entering the firewall and destined to a firewall device itself is handled by the input chain. Examples of this traffic are pings packets coming from any other device on any network and set to any one of the firewall's interface. Traffic originated in the firewall device itself and destined to somewhere else is handled by the output chain. Examples of this traffic are ping response generated by the firewall device itself. Then lastly, the traffic originated somewhere else and passes through the firewall device is handled by the forward chain. Examples of this traffic are packets being routed by the firewall. So we have some traffic that can be that comes out from the firewall to a destination, which we refer to as an output, and the input is one coming into the firewall to the interface of the firewall coming from there outside. While the forward rules is just the traffic that is passing through the firewall, so it's not really originated from the firewall, but passing through the firewall. So what we're going to do is the kind of rule that we're going to set is a forwarding rule, because it's originating from a host that is going to pass through the firewall to a destination. So what we're going to the returning traffic from the destination that is going to an internal host, so we want it to block it. So we are going to set a rule like this, an IP table. So -I means I forward indicate that instance of a new rule in the forwarding chain. You get it? So That means you can have dash out, dash outputs, or dash inputs, or dash forward. So okay, so then dash P TCP, you specify the TCP protocol. That means if it is TCP, like, or UDP, whatever protocol that you want to specify. Then dash D destination. So you specify the packet destination, so which is the IP address that we're going to put this time around. Then dash D port, this is specify the destination port. Then dash J drop, that to set the action. So we're going to use that option to set the actions to drop. Okay, so let's quickly run this now on our. So I'm going to come up with a new R1. So we have this to check our logs, and then the order to not to interrupt our IDNS. So I'll start another R1. So here now I'm going to set the rule, but before I set the rule, I can just quickly look at whether I have an entry for any rules set, and also to check some of the current list of rules there. We use dash after letter L dash B. Okay, so here now shows that here we have the chain input, and there is no current rule, there is no destination address, as you can see, and as well as forwarding rules. So we don't have any existing rules running now. So before we now, so let's now put our own by putting the rule. We have dash IP table, then we specify dash I forward dash P TCP dash D, that's the destination, then dash D dash D drop 66 and dash J drop. So this is the rule. So we set the rule. Okay, after we set the rules, then we can confirm again whether the rule now is supposed to have under this forwarding rule. Now it's supposed to have this rule set there. Okay, so now let's look at this table again. Okay, so on the forwarding rule coming up. Okay, good. Now you can see now under the forwarding rule policy, so we now have the rule that we just set now. Okay, so what we're going to do now is to so we go back to the host, and let the host try to see whether we can reach out to that particular malicious site again, server, and see whether you will be able to download this time around or not. Okay, so I'm going back to R5, and then so the R5 and have this here. Also, let's have our snots. Okay, so these are snots here, and then these are R5. So let's see what we're going to happen. So we can see here that they have this trying to send the traffic again. So what is happening now? So it's trying to connect, but you can see before it was able to connect 100% and then give us the results, but now it's not connecting again. So we can see you just try to connect and it won't be able. Why? Because the packet is dropping. Of course, it's not going to. The packet will continue to drop, and the destination will be unreachable. So you can see that on 5 now, what is happening on 5 is just connecting. Just trying to connect. And this is because we have set through, so the packet will continue to drop. Once it gets into the firewall will continue to drop the packet once the packet gets to the. So you can see now. So you can see the reply. It failed connection timeout, and then try. So it's going to. So it's the packet is dropping. That is what is happening. All right. So quickly, let's go back to the question now. So I think we have seen the purpose of our IDNS, and we have seen the purpose of the firewall. So if we come back to our question now, so in a complex network environment, a security analysts detect a suspicious traffic pattern. Just like the way we have detect someone is downloading a malicious software. So that indicate a potential advanced persistent threat to attack. So the analysts suspect that sophisticated attackers gain unauthorized access to critical systems and are attempting to exfiltrate sensitive data. So the organization relies on multiple security layers, including firewall, intrusion detection system, and endpoint security solution. What should the security analyst prioritize as the initial response strategy? What do we need to do? So, yeah, I think the best is for us to block where the suspicious traffic is coming from. So let's look. Isolate the compromised system. Of course, we need to isolate the compromised system and block what suspicious traffic can conduct a forensic analysis to identify the attacker and their method. A is the best answer. B say implement a network-wide password change for all users so that's not going to stop the attacker from being able to penetrate. I get it. So then when we conduct an external threat intelligence services to gather information on the APA groups, and that has still not stopped the traffic from coming into the network. And then we initiate a complete shutdown. That one is no way, because by the time you shut down, you are shutting down the services, and just because of one compromised system, so that will give us some downtime. So the best we can go for is A, by isolating a compromised system, block suspicious traffic, and conduct a forensic analysis to identify the attack and their method. All right, moving straight. So we have A as our answer. Going further, moving straight to the second question. The incident response team of an organization uncover a complex cyber attack involving multiple endpoints, advanced malware, and data exfiltration. So the team successfully contain the threat and prevent further damage. What should be the next steps in this investigation? Right, let's quickly talk about incident response. So NIST define this following 4 steps. So that first step in order to respond to incidents. And the first step has to do with preparation by the members of the site, that's computer system incident response team. They are trained in how to respond to an incident. So we have this preparation whereby the sites are trained. So at that time they are prepared to be alert for any kind of incident that will occur. So at this second stage has to do with detection and analysis. So which means through a continuous monitoring, the site quickly identify, analyze, and then they validate an incident. So which means preparations does with being able to monitor and respond to incident when it occurs, and once it has occurred, it moves to detection systems, and then they will analyze it, find out what kind of incident, so that they can validate that it's a false incident or valid incident. Are you getting it? So at this point of incident, second steps, detections, and they will be analyzed and validate that incident. And once that has been done, it moves to the third stage, which has to do with containment, eradications, and coverage. At this point, the site implements the procedures to contain the threat and eradicate the impact on organizational assets, and use backup to restore data and software. So at this point, they try to continue to make sure that it doesn't spread, and isolate the particular system and find a way to eradicate it. And once the eradication has been done, find a way to recover the system back to its proper function. Then after all that has been done on the third stage, it moves to the last stage, has to do with post-incident activities. And at this point, the site then documents how the incident was handled and recommend changes for future response and specify how to avoid a reoccurrence. So that is the last steps. So then if you look at our questions, which is basically based on the third step, on the third stage. So that's why I want to emphasize more on this third stage. By the containment, ensure that the incident does not continue. That is what the containment is all about. Different types of incidents will require different strategies. Do you strategize how to handle different incidents? For every type of incident, a containment strategy should be created and enforced. So during an incident, evidence must be gathered and documented in a clear and concise manner for subsequent investigations by authorities. And once we are able to contain that, we move to the eradication. Eradication is identifying all of the hosts that need remediation. All of the effect of the security incident must be eliminated. So that you eliminate any effect of that incident to that particular host. Then exploited vulnerability must be corrected or patched so that the incident does not occur again. Then still on this third stage is the recovery of hosts, whereby require a clean and recent backup, or they will have to be reviewed with installations. So this has to do with you bringing back that host into its normal function, into bringing him back to its normal function. And that's so we look at this now. Let's go back to our questions. So we see that the incident response team of an organization uncovers a complex cyber attack involving multiple endpoints, advanced malwares, and data exfiltration. So the team has successfully, which means they have successfully contained the threats and prevent further damage. And if you look at that, that has to do with the containment. Are you getting it? Containment. And containment is on the what? On the third stage. Are you getting it? On the third stage, which means this particular, what they're asking us that it has passed the preparation stage, that's passed the detection and analysis stage, is now in the third stage. And they've already passed through the first step in that phase 3. So what should be the next steps? So if they have already contained it, so which means they are moving into the eradication, and then as well as what recovery. So looking at our first option, assess the severity and the scopes of the incident and identify the affected systems. That's not it. And then conduct a post-incident. We haven't gotten into the first stage. C, say perform eradication measures. Yeah. Then followed by what? System recovery and restoration. So C is our best answer based on what we have analyzed before, what we have talked about. So definitely the third stage, they are in the third stage of so the next steps is to perform eradication measures, and then followed by system recovery and restoration. All right, so C is our answer to this. Then moving into the next questions, an engineer has created a bash script to automate a complicated process. During the script execution, these errors occur. That's permission denied. Which command must be added to execute the script? All right, so I'll quickly paint a kind of scenario whereby we get the same kind of permission denied, and we'll see what we're going to do, which is going to help us on this question. So I'm going to quickly log in back to my workstation. Logging back to the workstation here. Okay. Quickly let me quit this so that we can be able to get back our terminal. Then there. All right. So I have that now. So now I have a script here. Look at here. So I have this script. This script is just to configure a static IP for me. So let me quickly just open the script. So this script is called configure a static IP for me, and you configure my IP with this address 192.168.1.19, and this is the gateway you get. Alright, so I will try to run this script and see whether it's meant to go through. Alright, so then so come back to my terminal here. This /home/analyst, and this is the part to that script. I hope you look at it here, so I can actually get it from here. home/analyst/ log.support file/script. Alright, so then config. Oh, can you get that? So you can see like what we have in the questions. It's a permission denied. So this is a script, and giving us which means the user does not have permission to run the script. That is what this means. Permission denied. So let me confirm that now. So how do we do that? Now quickly let's look at the particular script and see the permissions that are that's associated to this script. ls. So I'll do ls-l. So ls-l/home/analyst. So this is still the particular file. I get it. ls means that I want it to list, and -l means that I want it to come with the permissions that are associated to the particular script. So then I have this now. So you can see that I have read write and without execution permission. So let me just quickly talk about that now. Okay, so when we have when we're back here now, in the Linux operating system has a total of 10 letters in the permission field. So there are 3 accounts that exist on Linux. So we have the user's account, the group account, and others. Okay, so if you look at what we have here, like these permissions that we have, D, R, W, X. Why the first field that stands for D? Sometimes it can be D, can be dash. So this D actually indicates that this is a file. This file has to be a directory. I get it. And then when we have from this second field where we have RWX, that is standard for the permission for the user. I get it. That is the user field. So which means like as this is concerned now for this student file, he has both read, write, and execute. So he can read and write and execute this particular file student. So then from this field of 5 to 7th field is the permission for the group. So it has a permission for the group. And then lastly, where we have from the 8th here, where we have the read to the execute here, so it's the permission for the others. So at least we now know that we now have the 3 accounts and their permission. So every file or Linux will have a permission for these 3 accounts. Every file will have a permission for these 3 accounts. So why we are having that statement before, let's go back to the terminal. Why we are having that statement before is because the user, which is an analyst here, does not have a permission. As you can see the permission of the user. You can see that the user can only read, write this particular file of the script. Are you getting it? But he does not have the right to execute it. So what we're going to do, can he be able to run this now? So we're quickly going to give it the permission to be able to execute. And so we'll do that by putting this command. So we're going to do change mode. That is the command. Change mode. Then U stands for the user. So I'm going to give a permission to the group. That will be G. And if it is other, I'll put O. Now, so the minus means that you want to remove the executable permission. But this time around, I'm going to say plus. Are you getting it? Plus means that I'm adding an executable permission to that particular file. And from here is the extension to the file. That is the path. Under home, analyst, under the lab.support files, then under script, and I have this config as static.sh, which is in bash script. Now, so let me run this now. Okay, so you can see that it was successful. But let's check whether we have the permission X. You can see what we have before, RW, but there is no X there. So let's see whether we now have. So I'm going to list with the permission again. Now we can see now that now has RWX here. Okay, fine. So now let's try to run the script, whether it's going to run now. Since this permission now, see this user now have a execution permission. So will it be able to run the script? So let's try to run it now again. So we'll try to run the same script /home support file scripts, then profit as static. So let's see. Okay, so I have to put the password there. So you can see that it was successful. It's not giving me permission denied again because we now have permission to execute the script. All right, so that's just the kind of the scenario of the questions we have there. So let's go back to the question now. So I believe we should be able to answer the question. So an engineer has created a bash script to automate a complicated process. During this script execution, this error called permission denied. Which command must be added to execute the script? So definitely it needs to change the mode and add an execution permission to that particular file. So this is standing for the command, and this is the standing for the execution permission, and this is standing for the script. So A is the best answer to this question. All right, answer is A. Okay, so moving straight to the next questions. What is the principles of infrastructure as code? All right, so let's quickly talk about infrastructure as a code. Now, infrastructure as code is the practice of managing and provisioning computing infrastructure through machine readable configuration file rather than through a physical hardware configuration or interactive configuration tools. Again, so when we are provisioning a computing infrastructure through a machine readable configuration file, this refers to as infrastructure as a code. Right, so we can have the term immutability refers to maintaining a system entirely. So infrastructure as a code, we are maintaining the system entirely as code, like a software, performing no manual operation on them at all. So we have like GitHub, which is modern infrastructure as code. GitHub is also referred to as operation by pull request. And then in a typical GitHub setup, we might maintain a repository such as a private repo on a GitHub, just the way GitHub runs, with several branches. So we can have all these different repository from where we can test onto the production, develop the app, test it to the production level. So you can run all that as a code. You can run it like that without knowing what infrastructures, running them as a code and files onto the production level, and then without having to put any hardware or anything to host that particular instance. You get, so that has to do with infrastructure as code. All right, so back to the question, what is the principles of this infrastructure as code? So we can see option A is a system maintenance is dedicated to software system. So I believe that's a very good answer. So like we said, that infrastructure as code, it runs and manages as system files and all that. So you are maintaining them like a software. That is infrastructure as a code. So option A, maintenance is dedicated to software systems. Okay, then B is a comprehensive initial design supports robust systems. C, script and manual configuration work together to ensure repeatable routine. Okay, so we're not talking about automation here or restrictions. So system downtime is put and scheduled across the infrastructure. So I'll go with option A. So option A is the best answer. So you can see what infrastructure stands for. Alright, so option A is our answer to this. Alright, then going further to the next question, which has to do with orchestration and automation. We need to drag and functions on the left onto the mechanism on the right. So before we do that, let's quickly talk about orchestration and automation. And so automation is about executing a specific task or processes automatically. So we have orchestration involve coordinating and managing these automated tasks to ensure they work together seamlessly and efficiently within a broader workflow. So that has to do with automation and orchestration. So looking at the scope of the two, you can say that automation focus on individual tasks or processes, while an orchestration manage the overall workflow and as well to coordination of these tasks and then managing the overall workflow. But in terms of the complexity between them, orchestration deals with complex multi-step workflow that involve various systems and processes, whereas automation typically handles simpler, more repetitive tasks. So it does a lot of repetitive tasks and handles this in a simpler way. So, but in terms of flexibility of the two, we can say that orchestration is adaptive and it can manage dynamic changes in workflow and resources requirement, while automation is usually more static and follows predefined instruction. So automation follows an instruction to automate. But in terms of orchestration, it can be adaptive and it can manage dynamic change in work. Alright, so with that, at least have an idea of what an orchestration and automation. We'll come back to the question. So the first one is saying create the set of executable tasks. When we are talking about creation, talking about arranging, I think that has to do with orchestration. So it has to do with orchestration. Then minimize redundant and streamline repetitive tasks. Whenever we are talking about repetitive, any kind of what does repetitive tasks has to do with automation? That is kind of an automation. So at least I can have something like this, whereby creating a set of executable tasks that has to do with orchestration, minimize redundancy, that's to do with automation. And to the third one, say organize a component to seamlessly run application. So that has to do with orchestration. So then systematically executing that task workflow has to do with automation. Right. So we have something like this as our answer. So it is organizing component to a seamless run application, creating the set of executable tasks. Those are orchestrations. Automation is minimizing redundancy and streamlining repetitive tasks, and systematically executing the large workflow. That's our automation task. Okay, so moving to the next question, I have talking about system handling. What is the purpose of handling system? All right, so quickly, let's quickly talk about system handling. And we can have host handling where we have our operating system, and we need to secure our systems, and that has to do with handling of system. When we are performing some security on the surface of your systems, that means you are trying to harden your system. So the operating system plays a critical role in the operations of a computer systems and is the target of the many attackers. So an administrator harden an operating system by modifying the default configurations to make it more secure to outside threats. And this process includes the removal of unnecessary programs and services. I get it. And remove it from the default settings, all that you are doing that to harden the system. Another critical requirement of hardening the operating system is the application of the security patches and updates. So you have to update and patch the system to meet up to the next system requirements, and so that you can harden the system to make sure we put some security features, new security features which can help your system to be more secure. So then you can also install anti-malware. Okay, so against malwares include your virus, your worm, your Trojan horse, keyloggers, and the spyware. So antivirus will protect you from that. They all invade the private and steal the information. Those are virus malware. So it is important to protect your computer and your mobile devices using reputable anti-malware software. Still on the host handling, patch management. So make sure that patch are code updates that manufacturer provide to prevent a newly discovered virus. So anytime the manufacturers of your applications and all that, once they discover there's a virus attacking your systems and all that, or there are some vulnerability to the applications, they come up with a new patch. So we have to always do a patch management to upgrade in next versions and of service pack. Host-based firewall. So with some host-based firewall, a software firewall is a program that runs on the computer to allow or deny traffic. And getting so firewall. So firewall can be host-based. It can have a software firewall or hardware firewall. So all this prevents you to inspect your traffic and filter it, every traffic, either to allow or drop the traffic. Then we can have host intrusion detection systems. A host intrusion detection system is a software that runs on a host computer that monitors suspicious activities. Then also try to make sure that you have a secure communication. So when connecting to a local network and sharing files, the communication between the computer remains within the network. So to communicate and share resources over a network that is not secure, user employ a VPN. So like internet that is not secure. So making use of VPN. VPN is a private network that connects remote sites or users together over a public network like internet. All right. Then for secure remote access, how do we do that? We can harden that by making sure that we are making use of it. Maybe like SSH. Should we replace your telnet from management connections? So you can manage remote access by that. Then in terms of trying to transfer file through remotely, so you can make use of SCP, secure copy. So securely transferring your computer file between two remote systems. SCP uses SSH for data transfer, including the authentication elements. So SCP ensure the authenticity and the confidentiality of the data in transit. So always make use of SCP in terms of file transfer. Right, so that's for hardening. And then for administrative measures, securing your ports and services. So make sure that you eliminate unnecessary ports and remove any unnecessary services that are running. Then privilege accounts. The cybersecurity exploit any privilege. So administrators use this account to deploy and manage operating systems, applications, and network devices. So this account should be secured or removed to to get this way. Then you can also create a good policy, that is administrative admin. So create a good policy. We have like Active Directory controller, main controller on the Windows server, which can allow you to create good policies like account policy, password policy, lockout policy. Getting it. So you can create a lot of policies and getting it with that. Then enable logs and the alerts so that you can always get information about what is going on the network. So, but before we add in the system, before system and device admin, auditing a system for potential misconfiguration or unprotected services is an important aspect of system admin. So I have Linux here, is an open source security auditing tools with automated scripts developed to test a Linux system. So I'll quickly log into my workstation, and then so that we can make use of this Linux to audit our system, so that we'll know what we need to add in on our systems, on our workstations. Okay, so we'll quickly log in. All right, so first of all, move to where I have my Linux app running there. So cd under download. Okay, go to the path download /Linux. Okay, so then into. All right, so then command to run my auditing. It says sudo /Linux. So that's to start the Linux. Since I'm going to do auditing, auditor, then what's the user? The user account is just Cisco. So the user account I've logged into is Cisco. So you can see Cisco at top 2. So then the audit. So you're going to audit everything about this account they get. So sudo, then the Linux app. So I have that. Then it's asking me for the password. The password. All right, so then the auditing starts. So the good thing about this is going to give you all suggestions, warning, where you have warning, suggestions. They need to suggest for you what you need to do. You can see that I'm getting a warning, checking for your password protection. So, and so on. So you're telling me that the password I'm using is very weak. It is very weak. I know that it's very weak because I want to show us that how we can audit. So you can see every different things that are involved, and that will help you to know how you are going to harden your systems, to put some security features on the surface of your systems. Okay, then continue to press enter to get more information, and then you can see somewhere I'm going to have under my kernel, so you give you some results applicable to that. So then if some the programs are running and not, let you know, to give you texture suggest for you if they are not well configured. You can see under the memory and processing. So it's telling me this is okay, this is okay, this is bad. Then you can see here those that not enabled. You can see checking for NS authentication support, not enabled. Yeah, I have suggestions. Checking part password strength too. So suggest it for me. So all this now, after you get all this work, at the end of it, everything is going to give you a summary, total warning, total suggestions, which you can take further to go and make research on how to implement them. So that is the purpose of this. So it's just to audit your system, get those information, research on it, and then implement it to harden your systems. Okay, so let's see different suggestions. That's mean under my 5 systems. Also there. So you have for my storage, these are what I have there. Then the TFL name services, as well as ports under my ports and the package. So I have that. So still coming up. So as auditing can always be done before, and it will help you with your hardening so that you know where to focus on. those ones that you need. Okay, so waiting. So I always will, after he has done everything, I'll have a suggestion of what to implement, which you can go for that research on how to implement them. So under my network, so to take to go into every different parts of your system and audit them for you. You can see warning: minimal of 2 responsive name servers. So you can see that it's saying this one is not running. Found 14 ports. Getting listening ports. Checking for malicious interface. And checking status of DHCP clients running. So we're going to have every details about your system. So just for you to look at where you need to. So let's quickly walk to the summary. SSH support. So you can see SLMP support. So it's going to take everything one by one and audit them for you. Right. So we want to move to the ending of this. So this is the summary. Okay, so get to the summary. Let's quickly go a little bit up. Consist suggestion, 35 suggestion. Set a password in the prompt loader to prevent altering boot configurations. Getting it. So defense suggestion, configure a minimum password. I guess configure a maximum password. So it's going to give you different option of what to do to get. So that is for holding. And you can see I have 3 warning there. Versions telling me that this version of this Windows I'm running is old and it should be updated, so that you can get more results, more findings, and you're getting new features for the new one. So that is there. So if we always do this, to do this auditing, then suggest what to be done and make research how to implement them. Okay, so that's for that. Okay, good. So that's about handling of systems. So let's quickly go back to the question. So back to the question: what is the purpose of handling a system? Yeah, option A, to securely configure machine to limit the attacks of it. Oh, that's the best answer. So we are handling has to do with you being able to put some security features on the system so that you can limit the attacks of the system. So option A is a good answer. Okay, that answer is A. Thank you all for attending today's class at 591 Lab. We hope you found these materials informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab. Help and support. If you have any suggestions or concerns, please don't hesitate to contact us. We appreciate your participation and then look forward to seeing you in our future classes. Have a good day.